December 14, 1940. The North Atlantic, 380 miles west of Ireland. A convoy of 43 merchant ships plows through swells that rise 20 feet and fall like collapsing walls. Wind screams across the deck of the SS Beaverford, a Canadian freighter riding low in the water, her holds packed with cargo that could turn the war. Below deck, 2,400 tons of aluminum ingots sit stacked 15 feet high. Each ingot weighs 25 kilograms, each one stamped with a serial number traced back to Arvida, Quebec, where it was poured 6 weeks earlier. The metal gleams dull silver under the cargo lights, cold to the touch, worth more than gold by the logic of 1940. On the bridge, Captain Thomas Morris grips the wheel with both hands. Ice crusts the windows. The convoy moves at 8 knots, the speed of the slowest ship. 42 other vessels spread across 5 miles of black water, maintaining position through the storm. Destroyers patrol the flanks, their sonar pinging into the depths. At 0340 hours, the port lookout sees it. A thin line cutting the surface, 300 yards off the beam. Periscope. Morris yanks the alarm. The Beaverford's engines roar as she turns hard to starboard. Behind her, a torpedo churns past, missing by 30 feet. The convoy scatters. Depth charges crack like thunder. Somewhere in the darkness, a U-boat dives deep, reloading. The mathematics are brutal. Britain needs 10,000 tons of aluminum per month to sustain aircraft production. Each sinking represents 50 Spitfires never built, 200 lives that might have been saved. Between June 1940 and December 1941, 127 ships carrying aluminum were attacked in the North Atlantic. 41 were sunk. This is the story of the 86 that made it through, 6 months earlier. May 10th, 1940. German panzers cross into France. Within 6 weeks, everything changes. Britain's aluminum situation in early May had been manageable, almost comfortable. Domestic smelters in Scotland produced 25,000 tons annually. France supplied another 40,000 tons from plants along the Rhine. Norway contributed 35,000 from hydroelectric smelters at Høyanger and Årdal. Together, enough to build fighters and bombers at a sustainable rate. Then the collapse. France surrendered June 22nd. Her aluminum plants, undamaged, fell to German control. 60,000 tons per year, now feeding Messerschmitt and Heinkel production lines. Norway had fallen earlier, April 9th. Wehrmacht engineers walked into Norwegian smelters, flipped switches, and resumed production. The aluminum that should have crossed to Britain now rolled east to the Ruhr. Air Marshal Hugh Dowding sat in his office at Fighter Command, staring at revised production estimates. The numbers were catastrophic. Britain needed 150,000 tons per year to maintain current aircraft output. It now controlled sources totaling 65,000. The shortfall, 85,000 tons. Without new supply, reserves would last 9 months. After that, assembly lines would go silent. On June 28th, Winston Churchill convened an emergency war cabinet meeting. The minutes, declassified decades later, record his exact words. "Gentlemen, the aluminum supply is now the crux of our air power. Without it, we cannot continue." One solution remained: Canada. The Aluminum Company of Canada, Alcan, operated the world's largest smelter at Arvida, Quebec. Current output, 90,000 tons per year. The British government sent contracts across the Atlantic. Triple production. Do it in 18 months. Britain had 9 months of reserves. After that, aircraft production would halt. The race was against time, distance, and 200 German U-boats. Arvida, Quebec, July 1940. Arthur Vining Davis, Alcan's chief executive, reads the British contracts in his Montreal office. Triple output in 18 months. The request is impossible. He signs anyway. The Arvida smelter sits on the Saguenay River, 150 miles north of Quebec City. 300 electrolytic cells hum day and night, drawing power from the Shipshaw Dam. Each cell pulls 150,000 amperes at 5 volts. Together, they consume enough electricity to power a city. Current production: 100 tons of aluminum per day. Britain needs 300 tons per day. That means 600 more cells. And 600 cells need power the dam cannot provide. Construction begins in August. 6,000 workers arrive by train and truck. The town's population doubles overnight. Men sleep in hastily built barracks, 3 to a room. Arvida's single hotel fills beyond capacity. Families rent spare bedrooms for $2 a night. The Shipshaw Dam runs at 90% capacity. Engineers calculate they need 40% more power. Emergency expansion starts immediately. New turbines arrive from General Electric in Schenectady, shipped north on flatbed railcars. Installation crews work through October's early snow, racing winter ice that could freeze construction solid. Inside the smelter, welders install new cell frames. Electricians string high-voltage lines. Bricklayers build refractory walls to contain the heat. The air smells of hot metal and welding flux. Accidents happen. In September, a crane cable snaps, dropping a 2-ton cell casing. 3 workers dive clear. 1 does not. Production climbs slowly. September, 120 tons per day. December, 180 tons per day. March, 1941, 250 tons per day. Every week of delay means fewer Spitfires over Britain. By March 1941, Arvida produces 7,000 tons per month. But it still has to cross 3,000 miles of ocean controlled by Admiral Dönitz and his wolf packs. Lorient, France. September 1940. Admiral Karl Dönitz stands before a wall map in U-boat headquarters. Red pins mark convoy routes across the Atlantic. Blue pins mark his submarines. He has 30 operational boats. He needs 300. Dönitz's strategy is simple. Wolf packs. Coordinate 6 to 8 U-boats against a single convoy. Attack at night on the surface where sonar cannot detect them. Overwhelm the escorts. Sink as many ships as possible before diving at dawn. German intelligence identifies aluminum shipments as priority targets. A freighter carrying steel can be replaced. A freighter carrying 2,000 tons of aluminum represents aircraft that will never fly. Dönitz issues standing orders. Aluminum cargo takes precedence over all other targets except troop transports. The Type 7 U-boat is Germany's workhorse, 67 meters long, crew of 44, range of 8,500 miles. Each carries 14 torpedoes. In the North Atlantic's killing zone, they are predators. February 9th, 1941. U-boat U, 96 intercepts convoy HX-106, 600 miles west of Ireland. The SS Ashby, a British freighter out of Montreal, carries 1,800 tons of Alcan aluminum. At 2,200 hours, 2 torpedoes strike amidships. The Ashby sinks in 11 minutes. 32 crew make the lifeboats. 7 do not. The aluminum settles 2 miles down. April 30th, 1941. U-552 torpedoes. The SS Nerissa, south of Iceland. Aluminum cargo and 84 souls lost. Allied convoys adapt. More destroyers. Better sonar. Depth charges dropped in patterns that crush submarine hulls like tin cans. Escort commanders learn to read the sea, spotting Periscope wakes in moonlight. The mathematics shift. In 1940, 15% of aluminum ships are sunk. In 1941, 22%. By late 1941, improved escorts drop losses to 11%. Every ton that reaches Britain requires sailors willing to drown in freezing water. Between 1940 and 1943, 2,400 merchant seamen die protecting aluminum shipments. Their names appear on no memorials. Liverpool, England. March 1941. dock workers unload the SS Beaverford under the blackout conditions. Cranes hoist aluminum ingots from the hold, 25 kilograms each, stacked on pallets. Each ingot bears a stamp. Alcan, 1941, followed by a batch number traced back to a specific electrolytic cell in Arvida. Trains carry the metal east. Castle Bromwich for Spitfires, Langley for Hurricanes, Chatterton for Avro Lancasters. At each factory, the ingots enter rolling mills where hydraulic presses flatten them into sheets 1/8 inch thick. Other ingots feed extrusion presses that form structural beams, ribs, stringers, the skeleton of an aircraft. A Spitfire requires 1,500 pounds of aluminum, fuselage skin, wing spars, engine mounts, control surfaces. Production rate in 1941, 320 aircraft per month. That consumes 2,400 tons of Canadian metal monthly. A Hurricane uses 1,200 pounds, 500 per month built? Another 300 tons. A Lancaster bomber needs 12,000 pounds of aluminum in its massive airframe. By 1942, factories produce 150 per month, 1,800 tons consumed. At Castle Bromwich, women operate the machinery. Mary Richardson, 32, formerly a Manchester housewife, now runs a hydraulic press stamping wing sections. She works 10-hour shifts, 6 days a week, earning £3, 10 shillings. The press exerts 1,200 tons of force. One mistake could crush a hand. Each aluminum sheet is inspected, stress-tested, tracked by serial number. Batch records trace every component back through Liverpool, across the Atlantic, to Arvida, to the specific cell that poured that metal. Spitfire serial number P-8331 rolls off the Castle Bromwich line August 1941. Its aluminum crossed in convoy SC-42. The aircraft shoots down 3 Bf-109s over Dover before taking flak damage in October. Declared unairworthy, it is scrapped. The aluminum is remelted, reformed, and becomes bomber parts. The metal fights the entire war. Between 1940 and 1943, Alcan produced 570,000 tons of aluminum. 470,000 tons reached Britain. 100,000 lost to U-boats, storms, and accidents that left no survivors to file reports. That metal built 20,000 Spitfires, 14,000 Hurricanes, 7,300 Lancasters. Without it, the Battle of Britain would have ended differently. Britain entered that fight with reserves for 9 weeks. Arvida's shipments arrived with 2 weeks to spare. Germany produced 250,000 tons annually, limited by coal-fired power and Allied bombing. Canada's hydroelectric advantage proved decisive. The SS Beaverford, attacked December 14, 1940, survived. Her cargo reached Liverpool January 3, 1941. By March, that aluminum flew as Spitfire wings over the Channel. December 1940 marked Britain's aluminum crisis point. Reserves dropped to 4 weeks' supply. Had one more convoy been lost, assembly lines would have stopped. Instead, Canadian ingots kept flowing. Jean-Claude Tremblay worked the Arvida smelter floor for 4 years. He never saw combat. He produced 15,000 tons of aluminum, enough for 200 bombers. Aluminum won no battles. It fired no guns. But without it, there would have been no battles to fight. History remembers courage and strategy. Beneath them lay 500,000 tons of Canadian metal, carried across frozen oceans by men who knew every voyage might be their last. Arvida, 1946. The smelter floor falls quiet. Workers go home. A single ingot remains, stamped Alcan 1941, now in a museum, unlabeled, unnoticed. The cost was never fully counted. 2,400 merchant seamen died in the North Atlantic protecting aluminum convoys. German naval records captured in 1945 show U-boat commanders received specific orders. Prioritize ships carrying light metal cargo. They knew what Britain needed to survive. In Arvida, the expansion left scars. 11 workers died in construction accidents between 1940 and 1942. Hundreds more suffered burns, broken bones, respiratory damage from fluoride fumes. The town's hospital, built for 4,000 residents, served 14,000 by 1943. The Saguenay River ran gray with industrial discharge for 2 decades after the war. Britain's official history, published in 1952, devoted 3 paragraphs to aluminum supply. The authors noted it as adequately maintained throughout the conflict. They did not mention the convoys lost, the workers injured, the margin by which disaster was avoided. Admiral Dönitz, interrogated at Nuremberg, was asked what single factor most frustrated his U-boat campaign. He answered without hesitation, "The convoys kept coming. We sank them, and they kept coming." They kept coming because men like Captain Thomas Morris steered through winter storms, because workers like Jean-Claude Tremblay stood in 120-degree heat pouring metal, because the alternative was unthinkable. The aluminum lifeline held. Barely, but it held.